downward steep angle up there.
Gotcha.
Now you guys give me the rest, because I truly was not listening to you.
Then you do 12 sine squared theta plus 11 cosine of theta, or x, sorry.
Actually, to be honest,
If
since we're putting this in integrand's position, it really doesn't make any difference.
Okay. Minus 14.
They're right, anti-differentiate with respect to x. Yes?
Very quickly, you later realized that you had to switch those, the balance.
Well, I realized initially, it's just something that stopped me.
Right, right. But suppose that, you know, you're doing this and you initially set them and then you realize you have to switch them. So is it necessary to do the negative sign to switch the values?
Yeah, you just go back and don't erase anything. Put a negative sign in front of everything, because I think when you switch bounds and integration, you change the sign of the integral anyways.
Right.
Yeah, good. But again, that's assuming, that's my assuming you understand you've made no mistakes along the way to come up with a negative value. I don't know, can you deal with this?
Yeah.
Yeah, I think we can. Actually, you know what, you guys? I'm running out of room. Can I just jump over here? Can I erase it? And so I think my integral is easily evaluated by doing what?
So about sine squared theta for 1 minus cosine 2 theta over 2.
Perfectly put. So I got the integral of 12 times 1 minus the cosine of 2x over 2. What's the rest? Plus 11 cosine?
Plus 11 cosine x minus 14.
You said minus 14?
Yep.
You guys, I'm serious. Can you help me with the rest? It was the inverse cosine. Was it 2/3? And it was 1/4?
Yeah.
But that nearly is going to be give me the integral of a negative 6 cosine 2x plus 11 cosine of a single x. Is that a minus 2? You guys, please double check my arithmetic. Don't just look at me. I've had the integral.
That's right.
I know you can evaluate. You're good.
Okay, negative 3 sine of 2x plus 11 sine of x minus 2x.
All evaluated from here to here. What was that? You know what oh, everybody. Linda, you're pointing out, I didn't make an arithmetic error. I'm so sorry. Look, 12 divided by 2 is what? 6. It's easy to fix that. And 6 minus 14 is not 2, but negative 8. When I put the negative 2 on the board, I made this mistake. I just considered the 12 minus 14. I forgot to divide by 2. Come on, you guys, be honest with me. You're being way too quiet. Is this okay so far?
No, it's going to be negative 8x.
Oh, thank you. I didn't finish at the end, did I? I had to continue to fix that mistake I made.
Why isn't it 11 over 2 times sine of x? Why is it just 11?
Clumsy hands. The anti-differentiate cosine of x, I just get sine of x.
Oh, okay, sorry.
But Reza, the reason why I divided by 2 here is because I made a use of my head. Since this isn't clean, I let u be equal to 2x. But that means du is 2 dx. I got to divide out by the 2 when I commit to that use of in my head.
Got it. But because the other one is just cosine of x and not cosine of 2. So.
Because that input's nice and clean, I didn't have to play that use of game. I agree. So you ready to evaluate? Are you ready to evaluate?
Sure.
No, you're not ready because look at that angle I'll call x. Shoot, I'm not taking the sine of x, I'm taking the sine of 2x. I don't like it. And you don't like it either, so tell me what to do.
Tell us why we don't like it.
Because the input's too complex.
Oh.
It's not just an x. I want it to be an x. So you guys
You're going to
are
have to
killing
use
me.
a double angle.
Thank you. I agree. The double angle identity for the sine function. Ah, shoot. Now we're ready to play. I think I misspoke. I'm not ready to play. I need a whole new board. So, diving in, I think what I have is nothing more than -6 times the sine of the angle whose cosine is 1/4 times the cosine of the angle whose cosine is 1/4 plus 11 times, is that the sine, of the angle whose cosine is 1/4 minus 8 times the angle whose cosine is 1/4. And I got to subtract off that antiderivative at the lower bound of integration. But that would be plus 6 times the sine of the inverse cosine of 2/3 times the cosine of the angle whose cosine is 2/3 minus 11 times the sine of the angle whose cosine is 2/3. And finally, plus 8 times the angle whose cosine is 2/3. Remember, we're still on a desert island. We have no calculator. But you guys take a peek at these angles real quick. Let me take a break. Look at this angle right here. Let's consider alpha being equal to the inverse cosine of 1/4. Doesn't that mean the cosine of alpha is equal to 1/4? And if I were to bed alpha in a right triangle, wouldn't that look like this? And if I were to embed this other angle, let me call it beta. Let beta be the inverse cosine of 2/3. Beta is merely an angle whose cosine is positive 2/3. And if I embed beta in a right triangle right here, to say this cosine is 2/3 means the ratio adjacent to hypotenuse is 2 to 3. Oh, by the way, with Pythagorean theorem, it just means the other leg has length √9 minus 4, which is √5. Ah, shoot. Now my life is an absolute piece of cake. Diving in, let's evaluate. I got -6 times, here we go. To sine up the angle alpha, look at the picture. Its sine is just √15/4. But the cosine of the angle's cosine is 1/4 is a piece of cake. It's just 1/4. Plus 11 times the sine of the angle alpha, but again, we already recognize that as a ratio of √15/4. Minus 8 times the inverse cosine of 1/4. Plus my 6 times the sine of my angle beta. But the sine of beta, looking at my picture, is just √5/3. The cosine of beta clearly is 2/3. Minus 11 times the sine of that angle beta again, which I've already recognized as √5/3. Plus 8 times the inverse cosine of 2/3. Life's not that bad, is it? Excuse me. You guys, it's cleanup time. Is that a 3√15? That very first term. All over an 8. Plus 11√15 over 4. Minus 8 inverse cosine of 1/4. And then I've got my plus, is that a 2 or 4√5 over 3? Minus my 11√5 over 3. Plus my 8 inverse cosine of 2/3. You guys hearing me? Am I doing okay so far?
Where's the, oh, never mind.
You sure?
Yeah, I was just wondering where that 6 times √5 times.
I was just simplifying.
Okay.
Is it? I need to know that.
Yeah.
It is. Can you check to see if I have any other sign errors before I finish? So I guess in the end, that's going to give me is that a total of 19/8 √15? And over here, is that a total of minus 7/3 √5? Plus my 8 inverse cosine of 2/3 minus 8 times the inverse cosine of 1/4. You guys, I don't know if there's anything else I could do to clean this up. I think that looks pretty. I hope you do. silence is killing me.
A lot of work.
It's not a lot of work, this is trigonometry, isn't it?
The last part of it, sure.
Man, I sure didn't get very far today, did I? Yikes.
To keep up with the curriculum, do you have to do like 2 sections a day? How's that?
You know, close to it. I have to do roughly 2 sections a day to keep up in the summer session. I think we're starting a little slow, but I think that's natural at the beginning. What's that? Because I don't think I can rush into my next section easily in 10 minutes. Can I suggest this, however? You guys help me where I can erase. Can I erase this over here?
Sure.
Are we done writing? Yes and no, is that a bounded region?
Yes.
And for me to find the area that's bounded region, let me show you how one way I can look at this. Just slightly different from what I've been doing so far. I can proclaim that I have an arbitrarily chosen rectangle, and I can compute its area. The area of the rectangle is nothing more than this high y value minus low y value. And so if I think of this point right here as x sub I comma y sub I, and this point down here as x sub I bar comma y sub I bar, then more conveniently, in setting up my integral to compute the area of that bounded region, I can just simply say this is the integral, in which I'm going to integrate with respect to
Y. X.
y. Well, that's the word, why not the letter y? Y. It does. I think the vertical rectangle needs my variable integrations x because the horizontal width of this rectangle is a delta x. And when I take the limit, this delta x goes 0 because